This video reviews the variable declarations and literals. Basically, we know that we need to declare a variable first before we use that. The general syntax for that is that if I want an integer variable named n, I use a keyword int as a type and the name of the variable. Once the variable n is declared, I can store an integer value for that, and then if I want, I can print the value stored in variable n using cout. So in C++, there are primitive data types like int. So to see the whole list of them, you can easily Google it with this keyword, C++ data types, W3 school. Then that page shows the complete list of that. So first, char types. So the keyword char is used to store any single character. So here I can use a keyword char, declare a variable named C. In C, I can store any single character. So single characters are represented by single quote. So here if I do this one, what I store is a uppercase A is stored that. So using cout, I can verify what is in there. So here I have another terminal side by side. So there the file name is a ch2.cpp. So let's compile it and then let's run it. So 20 is printed because of this part, and the next one A is printed where the variable C value is printed there. So here in this char can store any single character, but it says it's a value is something like this. What it means by that is what we store seems to be the letter itself, but inside the computer, instead of a letter, corresponding value is stored. So how do we know that is? If I want to store what actual value stored in variable C, I could put type int in parentheses, meaning that whatever is stored in C, let's change its type to integer value. Then if I compile and then run it, so 65 is printed. So in C, we stored uppercase A, but actually 65 is stored. So what is that is called ASCII table. So in search engine, so if I look for ASCII table, here is the ASCII table. So ASCII table is basically mapping between any character to a value. So in this table, what it says is as follows. So uppercase A, the decimal value is 65, but that's the mapping. So uppercase B is a 66 and so on. So space is a 32, exclamation mark is a 33 and so on. So this mapping table is called the ASCII table. So in C++, if you store a char value inside the computer, actually corresponding ASCII value is stored. But if you do cout with the char type alone, then the letter character is displayed like that. But if you want to see what is actually in there as ASCII value, you can do typecasting. Typecasting means by putting type name inside the parentheses, the value in C will be translated, changed into corresponding integer value, and that integer value is printed instead of a letter. So by doing so, you can verify what's in the ask table. So let's continue with the other types. So that's a chart type. So integer type, we have keyword int to store those ranges of value. If you say int only, it is actually unsigned int, so you don't have to type unsigned. The int means signed. You don't have to type signed. Int means just signed, which means the whole range is divided into negative value and positive value. But if you type unsigned, then you don't represent a negative value, so the range is just shifted to 0 and positive. So that is the unsigned integer can represent. Another integer type is short or signed short, the same thing. So short variable has 2 bytes in capacity, so the range is about negative 32,000 to positive 32,000. But if you do unsigned short, the whole range is for positive only, so 0 to about 65,000 is the range the short can represent. So what it means is that if I create a short variable named s, in s I can store only the short can represent. So in this example, short can represent signed short can represent negative about 32,000 to positive 32,000. So here you can type 32,767 is the maximum value you can store. But if you put a bigger number than that, like 8, that is not correctly represented. So let me show you what happens there. So here, this is the maximum value according to the table. So if I do cout, s is s, then let's compile the program and run it. So s is whatever the maximum value is specified. But however, if I give one more, like one more value, then let's just see what happens. If I compile, it says a warning, there's some error, so that's outside the range, so there's some problem with that. So let me do one more time, then let me just give the bigger number like that and then try to compile. So the error message shows up. So warning, there is some problem with that is not represented. But anyway, if I run it, what is coming out is a negative 32,768. So that's a not correct value. So when you declare a short variable, you are responsible, programmer is responsible for using that in the safe range. Another int type is long. Actually, that is the same as int. So there's no value distinction for that. Then we have a floating point type. So floating point type is to store real numbers. We have two keywords for that. So float type and double type. The ranges are different. The float is used with 4 bytes, and double is 8 bytes, so double can represent a way bigger value. So what is the actual maximum number the float can represent? That is specified here. Is a little bit difficult to read, but that is 3.4. So 3.4 times e means power of 10, and then the number plus minus is a power index. So this is the largest value float type can represent. While the double type, the power index is 308. So the largest value of a double is 1.7 times 10 base power. The power index is a 308, so that's the largest number the double type can represent. So when you use a float type or double type, so keep in mind that there is some limit the corresponding type can represent. So let's try those ones. So if I declare a float type, in float you can store some value with the fractions. Also you can store some value with the 10 base power. So you have 1.2 times 10 base power. The notation is E, and the power index is 3. So which means 1.2 times 10 to the power of 3. So 3000, that is the value you can represent. But here, let's see something that is, let's try to compile the code. That's for short type case. So let me suppress those ones. Let's try to print f is f. So let's compile again. Print. So that one is printed. So if you have another type called double, in D you can store huge number like 300 power, but in float it's the largest number is about 10 to the power of 38, so 300 cannot be represented. So let's print how the big huge number is printed. So compile and run it. So this is how the big number is displayed using E. E means a power of 10. That is a notation used for C++.